Hi there, my name is Ian Glish, and this is my presentation on American public versus private colleges and universities, a data-driven analysis of accessibility, costs, and success for undergraduates. The dataset analyzed was collected by the firm's consulting team and collected data on 1,302 colleges and universities, both public and private, across all 50 American states and Washington, D.C. The dataset had information on accessibility, various costs and entrance and graduation rates. Based on the original state of the dataset, I engineered 6 new features once receiving it that I could use to help me with my analysis. The purpose of this analysis is to help the consulting firm identify some meaningful insights that could help them advise various colleges and universities. I chose to focus on the differences between public and private schools, their overall cost, graduation rates, and factors that might be influencing those rates. My insights can help with a competitive cost strategy based on the schools being in or out of state, public or private, and looking at influences that could contribute to graduation rates and if that has any correlation with the school being public or private. The original size of the dataset was 1,302 rows by 20 columns, but I added 6 new columns through engineering new features. These features would expand my analysis. I focused on 6 total columns for my overall analysis. I cleaned multiple columns that had numeric data and filled the given columns with a median value based off those columns having many outliers. So I combined the columns together to have new columns that I could do analysis on. The outliers in the dataset were retained and were acknowledged as either extreme high or low values or possible input errors. I wanted to start out my analysis by seeing the public to private school ratio per state. The visualization shows that largely overall, about 75% of the states had more private schools than public schools. From there, I wanted to get a sense of the total cost of attending an in-state school for public versus private. Overall costs consist of tuition, room, board, additional fees, estimated book costs, and estimated personal money needed. In-state public schools have a much lower median overall cost and a smaller range of costs, even with outliers, compared to the median cost and cost range for private schools. For a total cost of out-of-state schools, the out-of-state tuition cost was used plus the same additional cost mentioned in the previous slide. Out-of-state public schools had a lower median cost and a smaller range of costs compared to the out-of-state private schools' median cost and cost range. These two cost graphs show that public school costs vary whether you are based in the same state or not, compared to private schools, which had the same cost regardless where you are located. I wanted to view my total cost observation using a different visualization, a scatter plot, to correlate the two different total costs to each other. There was a positive correlation for public school total costs. The left skew and the moderate height of the red clusters show that the out-of-state total costs were higher than in-state total costs. For private schools, the perfect positive correlation blue line shows that the majority overall of in-state to out-of-state total costs had the exact same number, besides a few outliers. For overall graduation rates for public and private schools, they nearly encompass the same range. Private schools had an overall higher graduation rate, shown by the right skew of blue bars, with a peak graduation rate of 65 to 75%, where public schools show a near perfect normal distribution with a peak graduation rate of 55 to 60%. From looking at the overall public and private graduation rates, I wanted to see if there was any standout factors that would be contributing to these rates. I decided to see if there was a correlation between percent of faculty with a PhD to graduation rate. This scatter plot showed a widely scattered output, not showing any direct correlations, but showing loose clusters based on public versus private, with public being broadly overall lower in all the dots and private being overall broadly higher, relatively showing that private schools had a higher percentage of faculty with a PhD and seemed to correlate with generally higher graduation rates. My last look at a potential standout factor that had an influence on graduation rate was to look at the correlation with the student to faculty ratios. This correlation was much less spread out and scattered, revealing denser clusters than the previous scatterplot visualization. That private schools had a lower student to faculty ratio that correlated with a higher graduation rate. Public schools had an overall higher student to faculty ratio and seemed to have a correlated lower graduation rate. In summary, public schools were the cheapest for in-state students and overall cheaper than private schools, but had lower graduation rates, while private schools were more expensive, but they had more graduation rate boosting qualities to influence their higher graduation rates. For actionable insights, public schools could reduce the student to faculty ratios and increase the number of faculty with PhDs to help influence increased graduation rates. Offering financial aid to out-of-state students could help grow interest from non-local students. For private schools, increasing financial aid to anyone that would qualify could help increase accessibility to prospective students. For the next steps, I would want to correlate both total cost to graduation rates to look for any correlation and try to collect data on how students are paying for college through scholarships, loans, financial aid, self-funded through work or from family or parents, and seeing those various methods of influence on graduation rates. Thank you for taking the time to attend my presentation. Please let me know if you have any other questions.